Hey everyone, today I'm walking through the repository architecture for my latest data analysis project, the Florida Housing Cost Burden Analysis. I engineered this real-world portfolio pipeline to uncover where households across Florida are being priced out of their communities with a strict localized focus on my home region, Manatee County, and its surrounding neighbors. As an alumnus of the University of Florida, it was an amazing experience to build this using raw, authoritative housing sheets directly from UF's Schimberg Center for Housing Studies. Before diving into the code, it was critical to ground the repository documentation in explicit domain rules. As you can see in the README file, we define housing cost burden using HUD's official metric, spending over 30% of combined household income on basic living costs. I also wanted to make sure reviewers and planners viewing this repo understood Area Median Income, or AMI, which maps earning brackets relative to a county's exact midpoint rather than relying on a generic, skewed statewide average. Instead of just writing an exploratory script, I designed this pipeline to programmatically answer 7 core real-world questions. The metrics listed here are computed entirely live by the codebase. For example, the pipeline isolates why Miami-Dade holds the highest burden rate in the state at 46.6%, proves that local renters are hit nearly twice as hard as homeowners, and demonstrates that 10 out of 12 everyday local occupations, including public school teachers and paramedics, cannot safely afford a typical 2-bedroom apartment on a single median paycheck. To execute this, I utilized a robust Python stack. I leveraged pandas for aggressive data cleaning and pivoting across 7 distinct source sheets: NumPy for statewide statistical aggregations, Matplotlib and Seaborn for static data distributions, and Plotly for high-end interactive choropleth maps. To ensure professional production standards, the directory structure enforces strict separation of concerns, keeping raw inputs in data folder, production outputs in outputs folder, and reproducible environments in the requirements.txt file. Finally, I prioritized reproducibility. The README file includes a clear, quick start guide so any engineer or analyst can clone this repository, run the environment locally, and seamlessly reproduce my exact visual and statistical results. If your team is looking for a data analyst or software engineer who bridges rigorous technical engineering with meaningful real-world domain insights, let's connect. Thanks for watching.